Just like the old saying, birds of a feather flock together. People who are similar to each other or share similar interests tend to spend time with each other. Clustering algorithms use the distance calculation method to divide all samples into different clusters based on certain standards. In this way, the samples in each cluster are similar, and the difference between clusters is more obvious. Based on this principle, we can use clustering algorithms to detect outliers. In the clustering result, these outliers are usually clustered together or independently, in some anti-fraud detection. These outliers are samples that need to be focused on. Another typical application of clustering is customer segmentation. Customers with similar habits and consumption preferences are grouped into a cluster to facilitate customer segmentation management and provide refined services for different groups. In this course, we use clustering algorithms to find the center of each cluster so that the sum of the distances from the center to each sample point in the cluster is the shortest. Clustering algorithms are classified in the following dimensions for partitioning clustering. A sample set is divided into k clusters in advance. The more similar the points in each cluster, the better. Typical algorithms include k-means and k-medoids. A natural disadvantage of partitioning clustering is that the value of k, that is, the quantity of clusters to be divided, needs to be manually set. This is usually determined based on some empirical rules or service requirements. Hierarchical clustering solves this problem. It uses bottom-up and top-down methods to decompose a dataset layer by layer. A third common clustering algorithm is density-based clustering. Partitioning clustering is to divide a dataset by distance. And density-based clustering is to classify datasets based on the density of sample points around a point in a region. Now, let's look at the technical principles of the three common clustering methods. This clustering method randomly selects k points, calculates the distance between each sample point and the k center points, and places the sample point into a cluster with the closest center point. After that, this method calculates the location of the center of each cluster again and uses the average values of all sample points as the coordinates of the new center point. After multiple iterative calculations are performed, when a location of a cluster center does not change, that is, after a result is relatively stable, the location of the center point is used as the final result. In the k-means clustering algorithm, the distance is used to measure the similarity between two samples. A shorter distance indicates a higher similarity. For example, if you rate a movie 4.5 points and your friends 4 points, but others may give only 1 point, we can intuitively feel that you and your friends may evaluate the movie similarly. Several methods are listed for calculating a similarity, where Minkowski distance is a relatively common method in clustering algorithms. It can be seen that when q is set to 1 in the expression of Minkowski distance, an absolute distance between 2 points is calculated. When q is set to 2, a Euclidean distance is calculated. The k-means algorithm uses the Euclidean distance to calculate the location of the center point of each cluster. The calculation is simple, and therefore the calculation speed of k-means is fast. However, this calculation method causes the center point of the cluster towards the outlier direction, which is easily affected by noise points. Another defect of the k-means algorithm is that the k-value needs to be set in advance, and it is difficult to accurately estimate the value. Therefore, the k-means algorithm is improved from two aspects: the selection of the center point and the clustering method. The k-mediads algorithm well avoids the problem that the k-means algorithm is easily affected by outliers. The k-mediads algorithm is another clustering algorithm based on partitioning. It selects an actual point in a sample as a cluster center, calculates the distance between each sample point and each center point, for example, Euclidean distance, and puts the sample point into the cluster with the shortest distance from the center point, similar to the k-means algorithm. These operations are repeated until the center point does not change. Both k-medians and k-means have obvious advantages and disadvantages. K-medians algorithm is not easily affected by outliers. However, this algorithm needs to calculate the distance between any 2 points in each cluster and then compare the distances to obtain a new centroid, which increases the calculation complexity. K-means only needs to calculate the average of each cluster to obtain a new centroid, which is efficient. For a large dataset, K-means is faster than K-medians. K-means double plus, which is different from the K-means in which K-cluster centers are randomly selected for the first time. Is assumed that P initial cluster centers have been selected, where 0 is less than P is less than K. When the next cluster center is selected, the point farther away from the current P cluster centers is more likely to be selected as the P first cluster center. Several methods of determining the k-value are provided. One method is to perform partitioning based on the spectrogram by setting a threshold. Another method is to select 2 or 3 variables to draw a scatter plot. In addition, some statistics may be constructed, and selection may be performed according to the statistics indicators. In addition to the preceding methods, we also need to consider the practicability. Take the case in this course as an example. We need to consider whether the cost of building a warehouse is greater than the reduced transportation cost. If the model effect for 3 clusters is similar to that for 4 clusters, but the construction and labor costs of adding a warehouse are much higher than the reduced transportation cost, it is better to build 3 warehouses. To resolve the problem of determining the k-value, we can also use hierarchical clustering. Hierarchical clustering can be classified into bottom-up clustering and top-down clustering. In bottom-up clustering, each sample is considered as a cluster, and the distance between 2 clusters is calculated. The nearest clusters are merged into a new cluster, and the distance between the new cluster and other clusters is calculated. The merging process is repeated until all samples are merged into one cluster. In top-down clustering, all samples are grouped into a cluster at the beginning, and the cluster is divided into a smaller cluster in each iteration until each sample is in a separate cluster. In hierarchical clustering, the distance between 2 clusters can be divided into minimum distance, maximum distance, average distance, and variance. Single linkage takes the distance between 2 nearest points in 2 different clusters as the distance of the 2 clusters. The method is susceptible to extreme values. 2 dissimilar points may combine because one of them is extremely close. In contrast to single linkage, complete linkage uses the distance between the 2 farthest points in the 2 clusters as the distance between the 2 clusters. Also contrary to single linkage, the 2 similar points of complete linkage may not be combined because of the extreme values in the cluster where the point was originally located. Average linkage calculates the distance between each point in 2 clusters and all other points, and takes the mean of all distances as the distance between the 2 clusters. The calculation amount of this method is relatively large, but the results are more reasonable than the previous 2 methods. The biggest advantage of hierarchical clustering is that you do not need to set the number of clusters in advance, but you can find the hierarchical relationship of clusters. In addition, hierarchical clustering can aggregate a dataset into non-convex shapes. However, hierarchical clustering requires complex calculation, and the algorithm is likely to be clustered into a chain. Density-based clustering determines whether a sample point belongs to a cluster by checking whether the clusters are closely connected. The typical algorithm is density-based spatial clustering of applications with noise. It determines whether a sample point is closely connected based on a group of neighboring parameters. There are several important concepts in the DESCON algorithm: the core points, boundary points, and noise points. We need to determine the number of sample points in a radius firstly. If the number of sample points around a point is greater than the value of minimum sample point threshold, the point is considered as the core point. Similarly, if the number of sample points around a sample point is smaller than the threshold but falls within the neighborhood of the core points, the sample point is called a boundary point. The points that are neither core points nor boundary points are called noise points. For example, in this picture, the red points are all core object. For each of them have 5 samples at least in their adjustment area if we set the minimum number of sample is 5. While the black point are boundary points. When we use DESCON algorithm, it randomly selects a core object with no category as the seed, and then finds the sample set with the density of all the core objects as a cluster. Then, another core object without category is selected to find the sample set with density, so that another cluster is obtained. Repeat above steps until all core objects have categories. The DESCON algorithm can process data with special distribution. It is insensitive to noise, and is fast. The number of clusters does not need to be specified, so it is applicable to large datasets. However, when the number of data dimensions is large, a dimension disaster occurs. After learning about these common clustering models, how do we select a proper clustering model? The evaluation indicators of clustering models are classified into external indicators and internal indicators. External indicators are used to compare the clustering result with a reference model. For example, the clustering learning result is compared with the division result provided by service experts. Internal indicators are parameters generated by directly examining clustering results without any reference model. Such indicators include mutual information-based scores, RAND index, and silhouette coefficient. In the mathematical expression of silhouette coefficient, A indicates the mean intra-cluster distance and B indicates the mean nearest cluster distance. Silhouette coefficient is the average of all sample silhouette coefficients. The value range of a silhouette coefficient is from -1 to 1. The closer the distance between samples in the same cluster and the longer the distance between samples in different clusters, the higher the silhouette coefficient. In addition to technical specifications, you need to consider the data scale, data distribution, and sensitivity to missing values or outliers, and sensitivity to the data input sequence when selecting a clustering model.